So hello guys, welcome back to my channel with me Rahmat in Tech Savvy with Rahmat. So we are going to talk about the Terraform short course, Terraform deep dive. So I am Rahmat, now country director of Indonesia and solutions architect at Tech Phoenix. So next slide. So this is me. So we are going to talk about the Terraform, but do I have capabilities to talk about it since I am certified in Terraform Certified Associate? So this is my expertise. So next, yeah, this is Tech Phoenix. So we are founded in 2012. We have 300 plus employees spread across worldwide. We have 11 plus years technology service. We also are partners with AWS, Oracle, HashiCorp, Heirloom, Snowflake, and Google Cloud. So this is our service. We have cloud service, cloud native application development, managed service, mainframe modernizations, data solutions, and advisory and consulting. So what is Terraform actually? What is Terraform? So why using infrastructure as code? So these three are the example of the console. This is the AWS console. This one is AWS. And this one is Azure. And this one is Google Cloud. GCP for short. A challenge is manual provisioning is slow and cumbersome. Provisioning infrastructure through point and click GUIs or custom script is slow, error prone, inefficient, and doesn't scale. We are talking about scalability here. This is the quote from the Infrastructure as Code book by Keith Morris. The enabling idea of infrastructure as code is that the system and devices used to run software can be treated as if they themselves are software. So what is Terraform? This is the official one from the Terraform. Terraform qualifies cloud APIs. So basically it qualifies the cloud APIs. So for example, in AWS you can use AWS CLI, which also making a CLI command line tools from the AWS SDK's API and declarative configuration file. So this is a declarative one. Adopt, build, standardize, and scale. Compose infrastructure as code in a Terraform file using HCL to provision resources from any infrastructure provider. Standardize, build infrastructure automation workflows to compose, collaborate, reuse, and provision infrastructure as code across IT operations and teams of developer, and scale using integrate with VCS, ITSM, and CI/CD. This part is not we are not going to cover this part. So first of all, how to install Terraform. So basically I use Mac, so this one is installing Terraform using Homebrew. Homebrew is a free open source package management system for Mac. Just use brew tab HashiCorp /tab and brew install HashiCorp tab /terraform and verify the installation using Terraform -help. Yeah, this one. And this one is one of the best practice. How to manage multiple Terraform version? We can use tfenv. Tfenv is Terraform version manager. So you can install it using brew install tfenv. So we are going to talk about Terraform syntax. The overview. Syntax of Terraform language consists of a few basic elements. which is the block type, block labels, and identifier and expressions. This is the argument. Block are containers for other content usually represent the configuration of some kind of object like a resource. For example, arguments assign a value to the name, they appear within blocks. Expressions represent a value either literally or by referencing and combining other values. They appear as values for arguments or within other expressions. Terraform syntax, this is the resource block. Resources are the most important element in the Terraform language. Each resource block describes one or more infrastructure objects such as virtual networks, compute instances, or higher components such as DNS record. This one. This is the example. A resource block declares a resource of specific type with a specific local name. For the local name, for example, this one is AWS instance and the name is web, and together must be unique within a module because they serve as identifier for given resource. This one is identifier. Note, resource name must start with a letter or underscore and may contain only letters, digits, underscores, and dashes. So next one, Terraform syntax data blocks. Data source allow Terraform to use information defined outside of Terraform, defined by another separate Terraform configuration or modified by functions. For example, data AWS EMI. Example, Terraform read from a given data source AWS EMI, AWS EMI, and export the result under a given local name. Example, we can refer this in the module later on. Data source and name together serve as identifier for a given resource and must be unique within a module. Provider blocks. Each blocks must declare this one. So there's a note in here. Each Terraform module must declare which provider it requires so that Terraform can install. It should be for the next one. So actually this one is for the provider itself. Provider is the one Terraform use for the plugins itself. And if working with multiple provider, if we are working with multiple provider, we can use alias. For example, this one is the for source and the dash. So these are two providers from AWS but use different. So each Terraform module must declare which provider it requires and the required version of Terraform. So this module, the required version is version 1.3 and the source is from AWS and the version is 5.7.0. This one, this is the identifier tag. So this one means it's like the maximum is 5.7. Some kind of up like 14, for example, if there's the latest one until the latest one version is 1.3, 1.5 is also included in here. And the next is the locals. A set of related local values can be declared together in a single local blocks. For example, the expression in locals are not limited to literal constant, they can also reference other values in the module. For example, I define region, AZs, and AMI as locals. How to use Terraform modules? a set of related local values. Oh, no, it's not. Modules are containers for multiple resources that are used together. A module consists of collection of TF or TF-JSON files kept together in a directory. So modules contain two parts. This one is the source one and the version. So the source is from the official HashiCorp modules. You can use like the path or GitHub or S3 for example. You can use path, file path, or you can use Git, or you can use S3 or other bucket. Other bucket. Terraform import nodes. Import blocks are only available in Terraform version 1.5.0 and later. Use the import block to import existing infrastructure resource into Terraform, like bringing them under Terraform's management. Unlike the Terraform import command, configuration-driven import using import blocks is predictable, works with CI/CD pipelines, and lets you preview an import operation before modifying state. This is the example. The import the ID of this to AWS instance example, and this is the resource one. One more, things are not covered: advanced CLI command, Terraform provisioner, scaling Terraform using CI/CD and Terraform GitOps, managing Terraform state, Terraform best practice, Terraform managed service, importing existing workload before Terraform into Terraform. So if you want more, please contact me, Rahmat Wibowo, Country Director of Indonesia and Solution Architect at Tech Phoenix. This is my email, this is the website, this is my LinkedIn. So this is our service offerings: cloud strategy, cloud migration, cloud modernization and automation, DevOps, FinOps, and cloud security. This is the cloud native app development, efficient cloud infrastructure, robust microservices, seamless containerization, streamlined CI/CD pipelines, optimized scalability, and ensured security. This is the managed IT service for digital success. This one is revolutionize your data solutions, scalable data storage, data analysis and insights, secure data management, and Snowflake. Harness the power of Snowflake with Tech Phoenix. Next one, we are going to talk about the demo. So, yeah, stay tuned.